Jupiter is so big that 1,300 planets of the size of Earth could fit into it. A planet dubbed TRES-4 makes the giant Jupiter seem less frightening, as it is 1.7 times bigger. The planet falls into the category of so-called puffy planets, which are planets of extremely low densities. The giant size and the low density are a combination that we have not yet seen. According to what science has taught us so far, this planet shouldn't be able to exist. Located 1,400 light-years away from Earth, the mysterious planet twirls around its central star, making a full circle only every 3 Earth years. The star itself is quite a theoretical problem for astronomers, as it is as old as our Sun, but much more advanced, emitting 3 to 4 times more energy than the Sun. Although quite an unusual parent star, it does not explain TRES-4's anomalous size. There is a rocky planet orbiting a star 480 light-years away, not that much bigger in mass or radius than the Earth. However, the planet seems to be the incarnation of the human idea of hell. The planet is home to rock rains and raging volcanoes. The temperatures vary drastically, with the side of the planet always facing the star reaching the temperatures as high as 2,000 degrees Celsius, with the far side of the planet always being under a cold shadow, reaching up to minus 220 degrees Celsius. With a molten surface, this planet is a hellish place, and it has been named Korat 7b, after the telescope that first discovered it. The planet closest to our solar system is orbiting its star at a distance of only 10.5 light-years. The planet is a gas giant, 1.5 times more massive than Jupiter, and it takes 7 years to circle its sun-like star. Because of its closeness, scientists predict that telescopes will soon be able to photograph it. It is still unclear if this giant has any moons, but scientists claim that if it were to turn out it was in fact circled by moons, it is very likely that the moons are similar to Earth, both when it comes to size and temperature, and they could be carriers of water, meaning a potential source of life. 4,000 light-years from Earth, a diamond planet is orbiting a small star. The giant diamond spinning in space is actually a dead star, and the diamond structure is the result of ultra-high pressures, causing carbon to crystallize. In other words, the dead core of a star is now classified as a planet due to the transformation it has endured. The planet is literally made out of diamonds, and it orbits a dense pulsing star smaller than our Sun. It orbits the star in a little more than 2 hours. Although it has lost a lot of its mass, it is still much bigger than the parent star it orbits. The 55 Cancri E is a planet classified as super-Earth, meaning it's twice the size of our planet, with temperatures that reach 3,900 degrees Fahrenheit. The planet is located 40 light-years away. Still, its size and mass aren't what actually makes it deserving of the title super. The planet is, in fact, the most valuable place in the universe. The rocky planet is made mostly of carbon, turned into diamond and graphite. If the planet were to be mined, it would be worth a total of $26.9 million. According to Forbes, mining only 0.182% of the planet would be enough to pay back the total debt of all governments in the world. It's one of the most familiar places in the solar system, near 24-hour day cycles, mountains, valleys, even liquid water. With so much in common with Earth, you'd think Mars could be a second home for the human race, but you'd be wrong. Mars is a violent, inhospitable wasteland, with nature firmly against you at every turn. But with that said, could humans live on Mars? From orbit, one thing is known for sure: Mars is dry. Although there is water ice and possibly even some flowing water, compared to Earth, Mars is a global desert. Not only is it dry, it's also absolutely freezing cold. On the hottest days on the hottest parts of the planet, temperatures can reach as high as 70 degrees Fahrenheit. That's actually not bad, but considering the average temperature of the planet is negative 52 degrees Fahrenheit, and with winter temperatures at the poles dropping to a bitter negative 225 degrees Fahrenheit, most of the planet is in a perpetual state of frigid hostility. Humans can survive in cold climates, however. The average temperature of Antarctica is about negative 57 degrees Fahrenheit, which is actually cooler than the average temperature of Mars, and we have a sustainable camp there. So although it won't be easy to stay warm on the Martian surface, it is technically possible with current and near-future technologies. But still, you'll have to plan your landing site accordingly. Entering the atmosphere of Mars introduces a unique problem. The Martian atmosphere is extremely thin. This means that air resistance for entering spacecrafts have less help slowing down as they descend to the surface. But this also means that there is little to no oxygen to breathe. In fact, the atmosphere is only about 0.14% oxygen compared to the 21% seen on Earth. There is light at the end of the tunnel, however. A chemical called perchlorate is found in high concentrations on the surface of Mars. This molecule consists of 1 chlorine atom and 4 oxygen atoms. Some oxygen atoms can be stripped away and collected, giving the astronauts a possible source of breathable air inside the habitat. On the downside, perchlorate is extremely toxic to humans. When it's absorbed, it interferes with metabolic functions. This leads to poor temperature regulation, sleeping disorders, and certain blood diseases. To date, there is no guaranteed way to keep this chemical dust from entering a habitat and into the lungs of any human inside. However, if there is a way to safely live in an environment with perchlorate, then it can be leveraged as an invaluable resource for the crew. One of the biggest dangers for anyone living on Mars is radiation. Because the Earth has an active iron core, a strong magnetic field is generated. This magnetic field shields the planet from harmful radiation, not only from the sun, but also from violent distant activity from deep space. In fact, in 2004, the largest single-ray gamma blast impacted Earth from a magnetar about 50,000 light-years away. It released more energy in 1/10 of a second than our Sun has released in 100,000 years. Unfortunately, Mars has little to no magnetic field, so it's almost completely exposed to the elements from space. Still, during a standard 180-day journey to Mars, the astronauts would have absorbed the same levels of radiation as a nuclear power plant worker will in a 15-year career. Once on the planet, the crew would continue to receive a constant low dose of radiation, increasing their risk of cancer further. Even with advanced shielding technologies and the Earth's magnetic field, radiation still poses a great risk for the crew on the International Space Station. Therefore, until radiation shielding techniques advance further, living on Mars will have to be scaled back to only a short visit. It isn't until you look at Mars, a seemingly Earth-like planet, that you realize just how narrow the habitability zone for humans actually is. Although we have technologies to get humans to Mars, on a planet that's 1.5 times further away from the Sun than Earth, and 225 million kilometers from Earth, with toxic soil, a scarce water supply, and dust storms the size of North America, you have to question whether it's even worth it. For some, it will be. And in the next 20 to 30 years, the technology will be in a place to help support human life on the planet. But today it is simply too far away and too hostile for a sustainable human colony on the Red Planet. Sorry folks, you're just gonna have to wait a little bit longer.